Hi, this is Mr. Roy. So I'm going to take you through the practice problems that we started working on in class. I believe we got through the odds 1, 3, 5, and 7, so we're going to start off at 9. Question says basically we're going to combine two solutions and what is the molarity of the new solution. So this is very similar to your lab, and what you are going to do is we're going to take the two solutions, the volume of the first and the molarity of the first. We're going to solve for moles. So if we remember how we solve for moles, we multiply the volume in liters times the molarity. And then we're going to do that for the second one. And so when we multiply these through, we get 1.05 moles from the first solution, 1.875 moles from the second solution. Again, add those two together and then divide by the new total volume. All right, so, and if we add those two together, we get 2.925. The total volume is 1.85. And when we divide, that gives us our molarity of moles over liters of 1.58 molar. So that's how we do question number 9. We'll go back up to the top. Now we'll start with the even problems. Number 2, it's asking how many grams of sodium sulfate are needed to make 0.600 liter sample of a 0.46 molar sodium sulfate solution. So first of all, we want to come up with the formula for sodium sulfate, Na2SO4. Molar mass is 142 grams per mole. And so basically we're going to start with our volume, 0.600 liters. We're then going to convert to moles by using the molarity of 0.46 moles per liter. And then to solve for grams, we're going to say that 1 mole is 142 grams. Then liters cancel liters, moles cancel moles, and our answer is in grams. And if you do that properly, you're going to get an answer of 39.2 grams. So number 4 looks a lot different than what you're used to seeing, but really isn't any harder than any of the other ones. So you got the formula for lead acetate. Pb has a +2 charge, acetate has a -1, so it is in a 2-to-1 ratio acetate to lead. And then you need to come up with the molar mass of lead acetate. That mass is 325 grams per mole. Then if you just start over here with your mass over volume, 10 grams over 1 centimeter cubed. 1 centimeter cubed is 1 milliliter. And since we want it to be a molarity, we need the volume to be in. So we convert it to liters. 1,000 milliliters in 1 liter. Now we have it in liters, so now we just have to convert the 10 grams to moles, and we do that by saying 1 mole has a molar mass of 325. And then grams cancel grams, centimeters cubed cancel centimeters cubed, milliliters cancel milliliters, and our answer will be in moles per liter. Do the math, and we end up with 30.8 moles per liter. Apologize for the background noise. I'm at my daughter's gymnastics, so if there's a lot of background noise. So hopefully this is kind of clear at least. Let's look at problem number 6. 6 is preparing a solution from a stock solution, which is just a dilution, M1, V1, M2, V2. We can call this V1, call this M1, and this can be M2. So we just plug those values in. If the initial volume is in milliliters, it just means that when you solve, your answer is going to be in milliliters. Your equation setup should look like this. And the answer is V2 should be 56.3 milliliters. So that's it. And then we'll look at problem number 8. 8 is also M1, V1, M2, V2. We can call this V1, this can be M1, and this can be M2. Plug it into your equation. And if you've solved properly, V2 is going to have a value of 4.13 milliliters. That's it. I hope this was helpful, and we'll see you in class.